All right, let's talk about two of the biggest buzzwords you hear everywhere these days, data science and data analytics. You've probably heard them used interchangeably, right? Well, today we're going to crack the code because they are definitely not the same thing. They're different roles with different skills and honestly, a totally different way of looking at the world. So what is the real difference? I mean, really? If you're maybe thinking about jumping into this field or you're just trying to figure out what everyone's talking about, this is the question you need answered. And by the time we're done here, you're going to have a super clear picture of how they're different, but also how they work together.
Okay, so to really get the players, we first have to understand the game they're playing. Let's zoom out and start with the big picture. What in the world is data science anyway?
I want you to think of data science as this huge umbrella. It's not just one thing, it's this mix of a bunch of different fields. We're talking statistics, computer science, machine learning, you name it. And they're all working together with one goal, to dig into massive amounts of data and pull out some real meaning. And as you'll see, data analytics fits right underneath this very big umbrella. And this right here, this is the absolute core of it. A data scientist is kind of like an explorer. They look at all the data and ask, what new, interesting questions can we ask that no one thought of before? On the other hand, the analyst is more like an investigator. They're given an existing question, and their job is to use the data to find the answer. So you've got exploration versus investigation. So with that foundation in place, let's zoom right in on the two key players in this whole data universe, the scientist and the analyst. First up, let's talk experience level, because this is a really common mistake people make. You don't just graduate from college and become a data scientist. It just doesn't work that way. The data analyst role, that's your starting point. That's the entry-level gig. Becoming a scientist is a senior position that takes years of hands-on experience and some seriously deep knowledge. And you can see how their focus is totally different too. The analyst is all about the what and the now. Questions like, what are our sales looking like this month? The scientists, though, they're focused on the why and the future. They're building these complex models to predict what's coming next and help shape the company's entire strategy. So what does it actually take to be a scientist? Well, yeah, you need the programming and the stats for sure. But the two things that are absolutely crucial are machine learning, that's using algorithms to find patterns and predict things, and something called domain expertise. You have to really know the industry you're in, whether it's finance or healthcare, if you're going to ask those truly game-changing questions. Now, for the analyst, communication is everything. I mean, everything. They have to be incredible storytellers. Their job is to take all this complicated data and turn it into charts and reports that are so clear that anyone, from the engineers in the back to the CEO in the front, can look at it, get it, and know exactly what to do next. All right, let's get a little more practical. Let's look at their toolkits. What software are these folks actually firing up every single day to get their jobs done? So the analyst toolkit is really all about getting the data, cleaning it up, and making it look good. They're living in SQL to pull information from databases, doing quick and dirty analyses in Excel, and then using powerful tools like Tableau or Power BI to build those amazing visualizations that tell the story. The scientist's toolkit, on the other hand, is built for a totally different scale. We're talking about absolutely massive data sets, so they need heavy-duty platforms like Spark and Hadoop to even process it all. And their advanced programming skills aren't just for looking at data, they're for building brand new, complex machine learning models completely from scratch. So whether you end up being an analyst or a scientist, the actual process of analysis tends to follow a pretty clear path. Think of it like a framework with 4 key stages. It's this really logical flow that starts with the past and pushes all the way into the future. First, you just describe what happened. Simple enough. Then you figure out why it happened. From there, you can start to predict what's going to happen next. And the final, most powerful step is to figure out what to do to make a certain outcome happen. So descriptive is the foundation. This is where an analyst really shines, creating those dashboards and weekly sales reports that just summarize what's already taken place. It's the baseline for everything else. Next, we've got to dig deeper. Why did sales suddenly drop last month? Diagnostic analytics is all about finding the root causes, looking for connections, and just trying to understand the story behind the numbers. And here's where we start crossing over into the scientists' turf. By using all that historical data and those machine learning algorithms, predictive analytics tries to forecast the future. This is how companies estimate things like which customers might leave or how much product they'll need next year. And finally, we get to the most advanced stage. Prescriptive analytics is amazing. It doesn't just predict the future, it tells you what to do to change it. The best analogy is a self-driving car. It doesn't just predict a crash, it actively steers the wheel to avoid it. That is the power of prescription. So why does all this matter to you? Well, let's pull all these pieces together and look at what a career in data actually looks like on the ground. This timeline pretty much lays out the classic journey. You start with a solid degree, then you get your foot in the door as a data analyst. For the next few years, you're on the front lines, getting really good at your craft. And then, after years of that hard work, you develop that deep industry knowledge and master the advanced stuff. And that's when you earn the title of data scientist. It's a path that's really built on experience. And that brings us to a really powerful idea to end on. It doesn't matter if you're an analyst or a scientist. Your real value isn't just in finding the answers. It's in mastering the art of asking the right questions in the first place. So the only thing left to think about is, what question will you ask next?